Hello everyone, this is dx+13y here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square y by dx square minus 6 into dy by dx plus 13y equals to 8 e power 3x sine 2x. Firstly, let's find the order and degree of the given differential equation. Identify the highest derivative. Here d square y by dx square is the highest derivative, so order will be 2. And highest power of the highest derivative is a degree is 1. Right? Now, we are given a differential equation, right, whose order is 2 and degree is 1. Now, let's write the given equation in operator form. Given differential equation, d square y by dx square minus 6 into dy by dx plus 13y equals to 8 e power 3x sine 2x. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write this equation as d square y minus 6dy plus 13y equals to 8 e power 3x sine 2x. Now take y common from the all three terms of LHS. We'll get d square minus 6d plus 13 into y equals to 8 e power 3x into sine 2x, right, which is an operator form. F of d into y equals to q, where f of d equals to d square minus 6d plus 13 and q equals to 8 e power 3x into sine 2x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of this non-homogeneous equation. And we'll find yp using 1 by f of d into q. Okay, so let's find yc and yp. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 6d plus 13, right? Let's replace differential operator by m, so that we'll get f of m equals to m square minus 6m plus 13, right? Now our auxiliary equation becomes m square minus 6m plus 13 equals to 0. Now we need to find roots of this equation. So let's find roots of this equation using the quadratic formula. M equals to minus b plus or minus square root of b square minus 4ac by 2a. Right? Now compare this equation with quadratic equation in M. Find a, b, c. We have a equals to quotient of m square 1, b equals to quotient of m minus 6, and c equals to 13, right? Then m becomes b minus 6 plus or minus square root of b square minus 6 whole square minus 4 into a, 1 into c, 13 by 2a, right? Which is equals to 6 plus or minus square root of minus 6 whole square. 6 square is 36 minus 4 into 1 into 13. 13 fours. 4 threes are 12. 4 ones are 4. 5. 52 by 2 into 1, 2. Right? Which is equals to 6 plus or minus square root of 36 minus 52. 6, 1, 16. So you'll get minus 16. Right? Again, we can write minus 16 as minus 1 into 16. Now we can split square root of minus 1 into 16 as square root of minus 1 into square root of 16 by 2. Which is equals to 6 plus or minus, since we know that square root of minus 1 is I and square root of 16 is 4. So we'll get 6 plus or minus I into 4 by 2. Now take 2 common from the two terms of numerator. We'll get 2 times 3 plus or minus I into 2 by 2. Here 2 gets cancelled and we'll get 3 plus or minus I into 2, which is a pair of complex conjugate. Then m equals to 3 plus or minus 12. So we got a pair of complex conjugate roots to this equation. Therefore, m equals to 3 plus or minus 2i are the roots of f of m equals to 0, our auxiliary equation, which is a pair of complex conjugate. We know that a plus ib is a complex number and its conjugate is a minus ib. If a minus ib is a complex number, its conjugate is a plus ib. So we can call m equals to a plus or minus ib as a pair of complex conjugate. So if we have m equals to a plus or minus ib, then yc will be e power ax into one constant into cos bx plus another constant into sine bx. Now let's write a complementary function. Yc equals to e power, for a equals to 3, we'll have 3x here into c1 cos. For b equals to 2, we'll get 2x plus c2 sine 2x. Now we got yc, right? Let's find yp now. Particular integral. We'll find particular integral using 1 by f of d into q. We have f of d and q, where f of d is d square minus 6d plus 13 and q is 8 into e power 3x sine 2x. Right? We can also write this as constant 8 into 1 by f of d into e power 3x sine 2x. So this is of 1 by function of d into e power ax into v form. We'll shift e power ax towards left by replacing d with d plus a, and later we'll operate v with 1 by f of d plus a. Right? So compare e power 3x with e power ax, then for a equals to 3, we'll find d plus a, which is d plus 3. Now shift e power 3x towards left by replacing d with d plus 3. We'll get 8 into e power 3x into 1 by replace d with d plus 3. We'll get d plus 3 whole square minus 6 into d plus 3 plus 13 into sine 2x. Then yp becomes 8 e power 3x into 1 by expand d plus 3 whole square, which is d square plus 3 square 9 plus 2 3s are 6 into d 6d minus 6 into d minus 6d minus into plus minus 6 3s are 18 plus 13 into sine 2x. So here plus 6d minus 6d gets cancelled. This becomes 8 e power 3x into 1 by d square plus 9 plus 13 plus 22 minus 18 into sine 2x. Now this becomes 8 e power 3x into 1 by d square. 22 minus 18 is plus 4 into sine 2x. Now this of 1 by some function of d into sine bx form, right? Now for b equals to 2, we'll find d square, which is given by minus of b square. Then d square becomes minus of 2 square, which is equals to minus 4. Now let's replace d square with minus 4 in the denominator. Always remember that the denominator must be non-zero. Okay, let's see what happens if we replace d square in the denominator. Okay, I'll take the denominator part. Then I'll get, just replace d square by minus 4, then we'll get minus 4 plus 4 equals to 0. Okay, what happens if we replace d square by minus 4 in the denominator is, we'll get 1 by minus 4 plus 4 into sine 2x, which is equals to 1 by 0 into sine 2x. We know that 1 by 0 is undefined, so total term becomes undefined, right? Which is not correct. So what we'll do? If g of d is d square plus 4, find g dash of d, which is 2d plus derivative of constant is 0, we'll get 2d, right? Now, write 1x into 1 by derivative of d square plus 4 is 2d into sine 2x, right? This equals to 8 e power 3x into x into, we can split 1 by 2d as 1 by 2 into 1 by d into sine 2x. Now we can write this as 8 into 1 by 2 into x into e power 3x into 1 by d sine 2x. We know that 1 by d is an integral operator. 2 ones are 2 fours are. We'll get 4x e power 3x into, find integral of sine 2x here. Since integral sine ax dx is minus cos ax by a, then we'll get, for a equals to 2, we'll get minus cos 2x by 2, right? This equals to 2 ones are 2 twos are. We'll get minus 2x e power 3x into cos 2x. So this is our required yp. Therefore yp equals to minus 2x e power 3x cos 2x. We got yc and yp, so let's write the general solution. The general solution is given by y equals to yc plus yp. Then our solution will be y equals to yc, we have e power 3x into c1 cos 2x plus c2 sin 2x plus yp is minus 2x e power 3x cos 2x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.